Hello everyone, good morning. Today we will be covering the chapter of purity, that is assay by UV spectrophotometer. Now what is UV spectrophotometer? UV spectrophotometer is an instrument which covers all the three ranges. That is, first one is 190, or you can say 200 to 400 nanometer. Nanometer is wavelength unit, which is with deuterium lamp. Second range is 400 to 800, that is tungsten lamp, which is called visible range. 200 to 400 is called ultraviolet range. 400 to 800 is visible range. For ultraviolet range, deuterium lamp is used. For visible range, tungsten lamp is used. In between, one more wavelength is there where you get the fluorescence. For that, we take mercury as a lamp, and the wavelength is 365 or 366 nanometer. Now, when we say assay by UV ultraviolet spectrophotometer, some of the pharmacopoeia, some of the monographs in pharmacopoeia, they give, actually you have to run always standard with the sample to find out the purity. But now in some cases they have given E1% of 1 centimeter solution, or absorbance of A, that is E or A of 1% 1 centimeter solution at particular wavelength, which gives some reading. That reading they are giving in the pharmacopoeia. In such cases, you don't have to take standard simultaneously. Otherwise, in most of the cases, you have to run same standard. What is standard means? Standard is a known sample or a known same powder of the drug having known percentage purity in it, which is already derived, taking reference standard into consideration. So when they are not giving any standard and E1% or A1% 1 centimeter is given, that means standard reading they have provided. You just have to prepare solution according to that and take the reading at particular wavelength when they are giving in the pharmacopoeia. Now again here, when they give E1% or A1% at particular wavelength, that means the sample gives maximum absorbance at particular wavelength which they have mentioned in the pharmacopoeia. For example, we can say paracetamol is a molecule where in many of the pharmacopoeias they have given E1% or A1% of 1 centimeter path length of the cell. What does it mean? 1 centimeter path length means the UV ultraviolet spectrophotometer. There are two types. One is single beam and double beam. Single beam means one cuvette, we can say a cell. The other word is you have to keep that cell and take the reading. In double beam, you have to keep your blank at the back side, and in the front side you have to keep your sample solution. Now here the cell size is also important. When it is saying 1 centimeter 1% and 1 centimeter, that means the cell of the UV cell, that is cuvette, are 1 centimeter in thickness and path length is 1 centimeter. Now there are different sizes available according to the concentration of the sample solution and reading what are absorbance we are going to get it. Now here one more thing is you should know that you can take absorbance or transmittance. You can take both. Sometimes they specify to take transmittance in some cases. Most of the time it is absorbance of the sample solution. Now how to read this E1% 1 centimeter or A1%? A is absorbance, E is extinction. For example, paracetamol has E1% 1 centimeter at 257 nanometer, reading is 715. Now, just if you go by exactly the terminology, the symbols, what they are, you will understand everything. Now, E stands for extension. 1% is 1% solution of paracetamol specified in the given media in 1 centimeter cell, UV cell, gives 715 as absorbance at 257 nanometer. This way you have to read it, and you have to prepare your solution in such a manner that it will give absorbance in that particular range. Now, in this, whenever we take UV spectrophotometer reading on UV spectrophotometer, whichever is the range, the correct range of getting the readings is between zero point 0.2 to zero point 0.8 absorbance. Now, why 0.2 to 0.8? Because this is the UV is, it depends on Beard's-Lambert's law. More the concentration, more the reading. That way you have to see. So your reading should be, you have to adjust your concentration of the solution in such a way that you will get your reading between zero point 0.2 to 0.8, which will give you more accurate results when you will compare with the standard or with the even percent what is given. So you have to prepare your concentration in such a manner that you will get a reading between this range. In next chapter we will learn how to prepare 1% solution and what is the range of UV. Now in this I will just conclude with the range of UV, that is UV spectrophotometer can give you reading between 0 to 4. The 4 is the highest scale. Now again I'll repeat, 4 one should not go for a higher readings. One should always get the reading between 0.2 to 0.8, which is a accurate range of the UV. Now again one more thing I'll add, whenever you compare with any standard or even the even percent of the sample, now I said paracetamol, here also whatever reading you are going to get it should be, if reading is specified like paracetamol they are given 715. Now your sample solution reading also should lie in between, close to that. How close? There is a limit for it. It's not like that whatever reading you will get and you should do it. No, there is a range for particular reading, that is 90 plus minus 3% of the reading. Means if 715 is the reading of paracetamol, so you shall have to calculate 97 to 103% of this reading, and you will get a range. So your sample reading should come in between that. That way only you have to take your sample weight and prepare dilution and get a reading in between that. It's not that you are going to prepare less solution and you will get less reading and you compare with that. No, it should always, the limit should be stringent enough to cover that absorbance. 100% perfection won't be possible because we are going, manual errors are there. So that's why there is a limit of range which covers all the errors, and they are given that you should be between plus minus 3% wherever values they have specified. Okay, I conclude here. Next chapter will go for how to calculate 1% 1 centimeter solution. How that percentage should calculate, that will cover in next chapter. Thank you.